Lessons 8 through 11 solution chart. After lesson 8, which was on solving multi-step equations, we filled out the first row. So this is when you're dealing with just one equation. After the solving systems of equation graphically, after lesson 9, we filled out the second row. So when we had intersecting lines, we had one solution. Parallel lines was no solution. Coincident lines was infinitely many solutions. Now that we've completed lesson 10, which is on solving systems of equations using substitution, we're ready to fill out the third row. When you're using substitution, there is at most 5 steps. Pause your video and write down those 5 steps now. All right, so step 1 is to isolate a variable. So you solve for the easiest variable. You could solve for x or you could solve for y. What you get after you solve for that easiest variable, you substitute that in to the other equation. That's step 2. Step 3 is to solve that equation after you substituted it in. So what we're going to look here is what you get after completing step 3. Okay, so this is after you have used the second step of substitution, you plugged it into the other equation, and you solve that equation. So again, this is after step 3. So if after the third step you get a variable equals a number, you get variable equals a number, so y equals 6, or x equals -2, or y equals -3/4, x equals 0.5, something like that. If you get a variable equals a number, it is going to be a one solution problem. And if you get a variable equals a number, that's when you continue on to step 4, where you take that and you substitute it back into the first equation and solve for the other variable. So your final answer in a one solution problem would be x equals a number and y equals a number, or the ordered pair x, y. So for these types of problems, you would look at examples 1 through 6 in the 10 notes. So examples 1 through 6 in the lesson 10 notes. So if you get a variable equals a number, it's going to be a one solution problem, and this is what your final answer would look like. All right, so if after the third step you solve the equation and you get a number does not equal another number. So 8 does not equal 4, 6 does not equal -6. Any number that doesn't equal another number. Or it could actually look like this up here, where your variable terms are the same but the constants are different. All right, so if you get that, then this is going to be a no solution problem. And this was example number 7 in the lesson 10 notes. Also put variables may cancel. Some people will recognize that if after they've done this step, if it looks like this, then it's no solution. Others might need to go on, and that's when two numbers are not equal to one another. And that'll be your no solution problem. All right, so if after the third step you get two numbers that are equal to one another, 12 equals 12, -5 equals -5, one number equals the other number, then that is infinitely many solutions. And this is example number 8 in the lesson 10 notes. So two numbers might be equal to one another, or it could look like this up here, where it's the exact same thing on both sides. For the majority of the time, you'll get two numbers that are equal to one another. But every once in a while, we'll come across a problem where it's the exact same thing on both sides, and therefore making that a infinitely many solutions. All right, so before you stop your video, please pause it. Make sure you have everything written down. I guess again we probably should put variables may cancel here also. All right, so make sure you have absolutely everything written down before finishing the video. If you have any questions, let me know.